Hello, in this video we are looking at learning intention number 48, which is on polynomial division. So you will remember this topic from last year, I'm sure. And you should have done this for your holiday homework as well. So I'm hoping this is just a refresher and you'll only have to do a few problems from the exercise to get back up to speed. This first one here wants us to solve this equation without a calculator. Oof. Look at that. 2x to the 4 plus x cubed minus 14x squared minus 4x plus 24 equals 0. We've got to solve that without a calculator. Well, there's one way to go about this really, and that's to factorize. So how are we going to do this? The first thing you need to do is give your polynomial a name. If you can give it a name, you've got a handle on it and you can work with it. So we're going to call it p of x, p for polynomial, and we're going to name our polynomial. Plus 24. Alright, there's our polynomial. Now, if you remember your factor and remainder theorem, you know that we're looking for an x value here that makes this whole thing just collapse to 0. That makes this whole thing equal 0. That's what we're looking for. And we just have to guess and check, looking for an x value that makes this thing equal 0. Let's try 1. Let's try p of 1. Well, that's going to be 2 plus 1 minus 14 minus 4 plus 24. Oh, this doesn't look too good. I can already see, without evaluating much further, we've got 3 minus 14, which is negative 11, minus 5, which is negative 15, plus 24. No, that doesn't equal 0. Let's try p of 2. So we sub in 2 minus 14 times 2 squared minus 4 times 2 plus 24, which equals 2 to the power of 4 is 16, times 2 is 32, 2 cubed is 8, 4 times 14 is 64, minus 8 plus 24. Alright, so that gives us 32 plus 8, which is 40. And then we've got 40 minus 72 plus 24. What does that give us? That gives us 64 minus 72. Alright, that doesn't look like it equals 0. I really thought it did. 32 plus 8, 40. I see, I've made a mistake here. Yep, I'm going to go back. Back we go. I see where I made my mistake. It won't even let me go back that far. Alright, so I looked back in my working and the mistake is here. 4 times 14 is 56 minus 8 plus 24. Okay, 32 plus 8 is 40, and then we get plus 24 minus 64. Then we get 64 minus 64, which gives us 0. Great. So if we sub in 2 and that all collapses to 0, this implies that x minus 2 is a factor. We've found a factor. This is very nice. We like finding factors. And now it's time for the super long polynomial long division. Let's set this up. So we have x minus 2. We have 2x to the power of 4 plus x cubed minus 14x squared minus 4x plus 24. Okay, long division time. Let's remember how to do this. So the first thing we do is we check. Here we say x times something gives us 2x to the power of 4. What's the something? Well, the something is 2x cubed, because x times 2x cubed is 2x to the power of 4. Then we take this term and we multiply it by this term, so we go 2x cubed times x, and we put 2x to the power of 4 here. Then we take this term again and multiply by this negative 2 here. So that gives us minus 4x cubed. Now if you remember, you subtract this off, so we get x cubed minus 4x cubed, which gives us 5x cubed. Okay, and these disappear because you've got 2x to the 4 minus 2x to the 4, they just disappear. So here you have x cubed minus 4x cubed gives you 5x cubed. Then you bring this one down here, the 14x squared, and then you follow through the same procedure. X times something gives 5x cubed. Well, that's 5x squared. So let's say 5x squared times x is 5x cubed. 5x squared times negative 2 is negative 10x squared. Then you subtract again. So we get negative 14x squared plus 10x squared is negative 4x squared. And then we minus 4x, and it's the same game again. X times something gives us negative 4x squared, so that's negative 4x. Negative 4x times x squared is negative 4x squared. Negative 4x times negative 2 is 8x. And then we play the subtraction game. Negative 4x minus 8x is negative 12x. We bring the 24 down. X times something gives us negative 12x, so that's negative 12. Negative 12 times x is negative 12x. Negative 12 times negative 2 is positive 24. Then we subtract, and then you're left with 0, which is great because we're left with 0, which means we've factorized correctly, and it means that, well, it means we've factorized correctly because x minus 2 is indeed a factor of this. Okay, where does that leave us? It leaves us with, and I'll just make some room here, it leaves us with p of x as, whoops, let's just get out of this one, leaves us with p of x as x minus 2, and then all that stuff in brackets, 2x cubed plus 5x squared minus 4x minus 12. Well, we've got another polynomial, and we're going to just have to find another factor. So let's name this part h of x. Give it a name. And we're pretty much just got to bash at it until we find something that makes it collapse to 0. Just a moment. Got to sip my tea. Alright, so we're going to make it collapse to 0. You always usually start with h of 1. Well, we'll try 1. So you get 2 plus 5 is 7. Minus 4 is 3. Minus 12 is negative 9. So that doesn't work. What about 2? Do we have a good feeling about 2? 2 cubed is 8. 16 plus 20, 36. Minus 8. Oh, it's not really working for us. Let's take a stab at negative 1. It's all about gut here. Just throw in your number, see how it goes. So that's negative 1 cubed is negative 1. So that's negative 2 plus 5 plus 4 minus 12. Oh, that doesn't look good. That doesn't equal 0. What else could we try? We could try negative 2. That'll give us something like negative 16 plus 20, which is 4. Plus, yeah, negative 2 looks good. h of negative 2 is 2 times negative 2 cubed plus 5 times negative 2 squared minus 4 times negative 2 minus 12 equals negative 32 plus 20 plus 8 minus 12. Is that right? Negative 2 cubed is 8. No, not 32, 16. Negative 16 plus 20 plus 8 minus 12. There we are. So we get 28 minus 28, which gives us 0. So that means x plus 2 is a factor. See how I'm always going back and checking my working if I'm unsure. I highly recommend you do that. In fact, on your exam, I remember on my exams, I did every bit of working twice. Anytime there was a bit of arithmetic, I would go over it twice just to make sure. So x plus 2 is a factor. And you guessed it, it's polynomial long division time. Our favorite time. Let's set that up. X plus 2 into 2x cubed plus 5x squared minus 4x minus 12. Alright, let's be a bit quicker with this one. X times 2x squared gives 2x cubed. Multiply that out by those. So you get 2x cubed plus 4x squared. Subtract these off, you get x squared, bring down to 4x plus x. Plus x, then you get x squared plus 2x. Subtract those off, minus 6x minus 12 minus 6 minus 6x minus 12. Beautiful, that gives you 0. Alright, we're getting somewhere. Sort of, slowly. We're pushing the peanut forward closer to our goal. Slowly, slowly, we're getting closer to our goal of factorizing this polynomial. So we get p of x equals x minus 2, x plus 2, 2x squared plus x minus 6. Okay, now this is a quadratic. This we can deal with. Let's use the cross method. That's got to be 2x and x. No worries about that. Let's take a stab at some numbers here. Let's try negative 3 and 2. Okay, 2x times 2 is 4x, minus 3x is x, but they don't work. Let's try 3 and negative 2. This is negative 4x plus 3x, negative 4x plus 3x, that doesn't work. Let's go back here. So we had negative 3x plus 4x. Oh no, that was the one, negative 3 and 2. 4x minus 3x gives you the x. So that's going to be our factorization. So we get x minus 2, x plus 2, then we get 2x plus 2, x minus 3. Is that right? Let's see, 2x squared minus 6. No, that's not right. I'm making mistakes all over the place. But I'm checking as I go. 2x minus 3, x plus 2. 2x squared plus 4x minus 3x. Yep, that's good. Alright, so these two terms we can stick together and we can make that a squared bracket. There we are. So even though I'm making mistakes, I'm checking them. I'm checking my working as I'm going. I'm like, oh, that doesn't make sense, or that doesn't look right. I encourage you to do the same. Alright, there's our polynomial, and we've got to let it equal 0. Finally, we can use null factor law. So we know that x equals negative 2, or x equals 2, or x equals 3 on 2. There's our answer. And you know what we say in the Maths Methods classroom? Let's check it on CAS. Check it on CAS. So there's a few things you can do to check this. You can do a straight out solve. Your solve function will do the trick. You can just put that right in. It'll solve it for you. But you can also factorize it on your CAS to check your answer. So the first thing we're going to do is actually tell the CAS what it is. So we're going to go menu 1, 1, and we're going to define our polynomial, p of x, so we can play around with it. 2 times x to the power of 4. And if I was a good student, I'd really do this in a document. I shouldn't be doing this in Scratchpad. Minus 14 times x squared plus 24. Done. That's defined. Now, factor. What you can do is you can pop over to menu, go down to algebra, and this should factor for you. I don't even think you need to put in a variable. I think it figures out the variable even. No, okay, maybe we need a variable here. Maybe we do need it. I think it's expand where it works without the variable. Okay, that's a bit odd. 2x to the 4 plus x cubed minus 14x squared. Oh, oops, I missed a term. Okay, grab this. Let's minus 4x. So we're going to redefine it. Minus 4x. There we are. Is that defined correctly? Minus 14x squared minus 4x plus 24. Good. Now we can go back up to our factor. Beautiful. See that? Same answer. Now you can also, with factor, it'll accept the variable as well. So if you put a comma in an x, it will give the same answer. I recommend putting the variable in, just so your calculator doesn't have to assume. So here it's just assuming x is the variable because it's the only variable. But if you had like an ax squared plus bx plus c, it won't necessarily know. So it's good practice to put in the variable there. And as always, you can use your solve function. Menu 3, 1, solve. Solve p of x. Let's find the zeros of p of x. Solve p of x equals 0. We're solving for x. Whoops. There we go. There are our solutions as we worked out there. Or we can of course use the zeros function, which you've seen before. So that's another way to do it. So that's our answer. We can tick that off. Now, example 2. This is much shorter. This video is going for much longer than I expected. Probably because polynomial factorization is a pain. Example 2. Okay. Find the value of a if x plus 3 is a factor of this. So let's define our polynomial as p of x, give it a name, and now we're looking for a value to put in here that's going to make it equal 0. Well, this is a factor. Remember, if this is a factor, then that implies that p of negative 3 must equal 0. This is the fact we're going to use. So p of negative 3 is 0. So 0 equals 2 times negative 3 to the power of 4 plus a times negative 3 cubed minus 3 times negative 3 plus 18. So that's 0 equals 2 times negative 3 to the power of 4 is 81. This is negative 27a. This is plus 9. This is plus 18. This is 162 minus 27a plus another 27. 162 plus 27 is 189 minus 27a, and this all equals 0. 27a equals 189. A equals 189 on 27, which reeks of a factor here. There's definitely 9 goes into both of those. 9 goes into their how many times? 21 times. 9 goes into there 3 times. That's 7. A equals 7. But don't trust me. Check it on your CAS. So what can your CAS do for you? This CAS calculator can do this problem for you. If you know how to use your functions, it can do this for you. And I'm going to show you a couple ways. I'll show you two ways in fact. So let's calculate. Okay, so the first thing you do, menu 1 define. Let's define function. Menu 1 define p of x equals 2 times x to the power of 4 plus, now watch out here, it's a times x. You have to tell your calculator a times x. If you put ax, if you just put ax, it'll think x is like a variable. So you need to put a times x. So it knows minus 3 times x plus 18. Alright, that's all well and good. It's defined, so you're probably thinking, well, so what can you do? How can your CADs help you here? Well, what you can do is you can use the solve function and you can put in the conditions. Look, I'll show. Let's just have a play around. Let's just try p of -3. P of -3. What does that give us? Can you see that already? Your CAS has done a lot of the work for you. It's figured out, it's subbed in -3 there, and it's taken you to 189 minus 27a. So already you could go from that line and then you could solve for a that way. Another way you could do it is with the solve function. Now I've got to think about this. We want to solve for p of -3 equals 0, and we're going to have to put an and in here. So we've got p of -3 equals 0, and we want to solve for a. So you can see that it's saying p of -3 equals 0. Now tell us the value of a. Can you see how that's working there? This here is this function, p of x. We're saying, well, p of -3 gives you 0, so tell me what a is. Another way you can think about it is p of -3 is that thing there. So that thing there is the same as that thing there. So it's the same as saying solve, if you wanted to do it in more steps and understand what's going on. It's the same as saying solve 189 minus 27 times a equals 0 for a, like that. That's another way to think about it. If you liked, you could do it with the zeros function if you want to write less. So we could go to menu 3, 4, and you could just, I like zeros here because zeros is actually what's kind of happening. Like you're finding the zeros. You could go p of -3, p -3, chuck a comma, solve for a. Whoops, I put in extra brackets. Solve for a. There you are. There's your 7 as well. That's another way to do it. So we can give ourselves a tick there. I hope that's refreshed your memory on factor and remainder theorem and polynomial division. And if you have been, thanks for watching.